Hi, for day 3, what we're going to do is take a look at geometric mean when you have similar triangles, and then I'm going to show you what I consider to be a trick for this, which is what I call pencil patterns. But just again to refresh your memory, this whole chapter kind of revolves around proportions, and to solve a proportion you cross multiply. Now, what we're going to do today is take a look at what happens with a geometric mean. So we'll get there. In a proportion, again, we can say that the product of the means is equal to the product of the extremes. Now, that wording will become very, very important when we get to actually writing proofs. But for now, let's just make sure that we know where the means and the extremes are. Again, I said on day 1 that if you write it with a colon, so A to B equals C to D, it's a little bit easier to pick out the means and the extremes. The means are the things that are in the middle of that equation. So B and C would be the means. And the extremes then would be A and D. Those are the things furthest to the outside. All right. With a geometric mean, the same number is always in the means place. So it would be something like A over X equals X over D, and X, that thing in the means place, is the geometric mean. It's the same thing. Now, if we want to find the geometric mean here, what we want to do is set up a proportion. So we put 2 and 8 in the extremes place, and then we solve for the mean. So we would end up with something like 2 over X equals X over 8, and then we would cross multiply. When we cross multiply here, we end up getting X squared equals 16, and if we take the square root of both sides, we end up getting X equals 4. All right, the other thing that you can do is if you're given the geometric mean and one extreme, and you could be asked to find the other. So if the square root of 24 is the geometric mean between A and B, find B when A is 2. So again, we know A over the geometric mean equals the geometric mean over B. So if I set this up as a proportion, I have A, which is 2, over my geometric mean, which is the square root of 24. And that's equal to my geometric mean, again, square root of 24, over B, which is what I'm trying to find. Now, when I cross multiply here, 2 times B is 2B. And the square root of 24 times the square root of 24 is 24. And if I then divide both sides by 2, I get that B is equal to 12. Okay, so the other extreme would be 12 if my geometric mean was the square root of 24, and one of the means is 2. Or one of the extremes is 2. All right, so when do we use geometric mean? If you have a right triangle with an altitude drawn, sorry, I have awful typing skills, with an altitude drawn from the right angle to the hypotenuse, then what happens is we end up with a whole bunch of similar triangles, and we end up using the geometric mean. So what we have here, again, here's our right angle. We have an altitude drawn from the right angle down to the hypotenuse. What happens is you end up with similar triangles. This triangle right here, ABD, is similar to the triangle BDC, and both of those are similar to the great big triangle ABC. So we end up really with three similar triangles. We have the tiny one, which is the one that's kind of over here. We have the medium one, which is this one, and then the great big one, which is the whole thing. And again, all of them are similar. Now, one thing that we can do is set up a whole bunch of proportions. So if we take a look at this tiny triangle and the medium triangle, we can compare the short side to the medium side. So the short side on this triangle is AD. So up above here, I'm just going to open up a fraction. We can compare AD to the medium side of that triangle, which is BD. And then we can compare the short side and the medium side of this medium triangle over here. And we end up with the short side being BD and the medium side being DC. And if you notice, we end up getting a geometric mean here. The thing in the means place is the same. Now, what happens is that you can actually just trace along the triangle and end up with that proportion. So if I start at A and I go to the altitude, I've just traced over the short side. If I go up the altitude, I traced over the medium side. If I go back down the altitude, I've traced over the short side of this triangle. And then if I go down along the bottom, I've traced over the medium side of that triangle. So basically, if you take your pencil and you start on one end of the hypotenuse, go to the altitude, up, back down, and all the way over to the other side, every single thing that you trace over goes into your proportion in that order. So we start over here on one side of the hypotenuse, go to the altitude. That number that you just traced over is the top of your first fraction. Go up the altitude, that number that you just traced over is the bottom of your first fraction. Go back down, that number again goes on the top of your second fraction, and then again all the way over to the other end of the hypotenuse, and that's the last number of your fraction. Okay, and so that's why I call it a pencil pattern, because if you trace your pencil over the shape, it basically tells you how to set up your proportion. Okay, second proportion that we can set up is comparing the medium side to the hypotenuse. So for this one, we're going to take a look at the medium triangle and the great big triangle. So on the medium triangle, the medium side is DC and the hypotenuse is BC. So our first fraction is the medium side, so on the bottom, the side that goes from D to C, and then we go up the hypotenuse from C to B. Then, if you take a look at the great big triangle, ABC, the medium side is CB, and the hypotenuse is AC. So we set this equal to CB over CA, and again, we end up with that geometric mean, CB. Now, pencil pattern, for this one, you start at the bottom of the altitude. So start at the bottom of the altitude, and you move towards the side where the medium side of your right triangle. So if I start at D and I go towards the end of the hypotenuse, that's the top of my first fraction. Travel up to the top of the triangle, that's the bottom. Back down, that's the top of my second fraction, and then all the way across the bottom. Hey, buddy. All right, so again, pencil pattern for this one. Start at the bottom of the altitude, go towards one side, up, down, and then all the way back across. And again, same thing for this last one, except we start at the bottom of the altitude and we go towards the short side. So for this one, we're going to compare short side to the hypotenuse. So again, we're looking at the small triangle and the great big one. So the first fraction, if we start at the bottom of the altitude and we look at the short side of the small triangle, we have AD. The hypotenuse of that short triangle is AB. And then we set it equal to the short side of the big triangle is AB, and the hypotenuse of the big triangle is AC. Now again, we end up with that geometric mean. AB is kind of the common link. So really, if you are thinking about this, we really have two cases. With this one, the first one that we looked at, we know something about the altitude. So if you know something about the altitude, you start at one end of the hypotenuse, go to the altitude, up, down, back over. If you don't know anything about the altitude, but you know the sides, you start at the bottom of the altitude and you go towards the side that you know. You start at the bottom, go towards the side that you know, up, down, and then all the way back across. Okay, for the problems from your packet, what I'm going to do is start with number 1 and just go through a couple of them with you. What I want you to think about when you're looking at a problem where you're going to use the geometric mean is, do you have any information about the altitude? If you have information about the altitude, then you start at one end of the hypotenuse, go to the altitude, up, down, and back over. If you do not have any information about the altitude, then you start at the bottom of the altitude and you go towards the side where you have the most information. So what I'm going to do is start with number 1. Number 1, we do have information about the altitude, so we're going to start at the end of the hypotenuse, go to the altitude, up, down, and back over. Every number that you cross goes into your proportion in order. So the first thing we crossed over was 9, then x again, and then 16. Now it's just a matter of cross multiplying. So in one direction we get x squared, and in the other direction we have 9 times 16, which is 144. If we take the square root of both sides, we end up that x is 12. Alright, the second one, we do not have any information about the altitude, so we start at the bottom of the altitude and we go towards the side that we have the information. It looks like we have a lot of stuff over here. We have more stuff over here than the other side, so that's the side that we're going to go towards. So we go to the end of the hypotenuse, up the side, back down the side, and then all the way across. Now, what we crossed over when we did that, first thing was a 9, then our x, then x again, and then we crossed over 9 and 16. Well, if you add 9 and 16 together, you get 25. So the length of that side was 25. Then we cross multiply, and we end up with x squared equals 225. And then if we take the square root of both sides, we end up with x is equal to 15. Okay. Again, same thing down here. We do not have any information about the altitude, so we start at the bottom of the altitude and we go towards the side that we know the most information about, which is over here. So we cross over the 36, cross over the x, back down the x, and then all the way across. So when we do that, we end up with 36 over x equals x over 100. Okay, again, when you crossed over this long side, you crossed over 36 and 64. Altogether, that side is 100. Alright, so I'll leave that one for you to cross multiply and figure out. And that should be it for today.